Okay, so it is recording with all the feedback. I don't know how to tweak it to get rid of the feedback. Maybe, oh, I can see it. Is that better?
Yes.
Yeah, somebody cranked the treble all the way up, so the high frequency is amplified unnecessarily, and that's why it's feeding back a little too much signal. All right. All right, first question. A, B, C, and D are all bits, binary digits. These bits are arranged as 2-bit numbers. So AB is one number, CD is another number. In the case of AB, A is the most significant bit. In the case of CD, C is the most significant bit. Consider the subtraction, AB minus CD. So we have a 2-bit subtraction here. Enumerate, basically lists all the possible bit patterns that end up with the overflow flag being set. Use the following table to list all the bit patterns. You may not need all the cells. Okay, I forgot to put a not in the description. Each number should be a 2-bit number with all digits specified, which means you have to specify all the leading zeros. So don't leave anything as implied. Okay? Are there any questions about this? Well, the question is asking. Say again?
Subtraction.
Yeah, it's basically we're dealing with 2-bit subtractions, and there are 16 possible combinations. However, the overflow bit means the result, the sign of the result does not make any sense. Okay, you guys do remember that? Do you guys remember the equation to compute the overflow flag? We talked about it in class.
Not A, C, D plus A, not C, not D.
And that spells out the answer.
I'm looking at
Yeah.
the first bit.
Yep,
Bit of
the most significant bit
and
of the numbers and also the result. Yep. Okay. All right. So, but we can potentially enumerate all the possible cases too. And then the other way to look at this is the result of the subtraction can no longer be represented using 2 bits. That's the other way to look at it. Okay? So you have to think about, in what case, the result can no longer be represented. And this is subtraction. So if I, use the most negative number that we can represent here already and subtract 1 from it, then the result cannot be represented. So 1, 0 is representing -2, which as a 2-bit number is the smallest value I can represent. If I just subtract 1 from it, then I can no longer represent the result. But if you think about it from the sign perspective, we have a negative number and we are subtracting a non-negative value from it. But the result is going to be what? 1, 0 minus 0, 1 is?
Which is negative.
Is 0, 1. Is 0, 1, which is non-negative. So you subtract a non-negative value from a negative value, and you end up with a non-negative value. Overflow is set because the sign of the result does not make any sense. Is that okay? All right. So the other way around is you have a positive number, you subtract a negative value from it, and you end up with a negative value. Is that okay? So you think about the most positive value you can represent using 2 bits. Which one would that be? 1, 0, 1 to be exact. Okay? So you say, okay, we start with 0, 1, and we subtract the most, we subtract any value from it. Okay? We subtract 0, 1, let's see, we subtract a negative value from it. There's only 1 negative value, but there are 2. So we subtract the -1 from it. What is the result of this subtraction? 0, 1 minus 1, 1. What is the sign bit of the result? Sign bit is a 1. Okay? So you start with a positive number, non-negative number. You subtract a negative value from it, but you end up with a negative value.
Right.
The sign doesn't make any sense. Okay, so this is the second one. But you can also do this with an even more negative value, which is 1, 0. So you can do the calculation. 0, 1 minus 1, 0 is 1, 1. The sign is wrong too. So I think these are the only 3 possible wrong answers. I think I might be missing one here. I think there's a 1, 1. Nope, this is it, because this is the only non-zero positive value. So that's it. There are only 3. Any questions? Does anyone come up with any more than these 3? No? So I think that's it. Did anyone go through all 16 possible cases and just try to figure it out?
But I don't think I did it
I
right.
checked my answer.
Okay.
I just wrote on the numbers in it.
Positive,
Okay.
When I was
negative,
doing it.
negative.
But did you guys see how I did it? I
Yeah.
just reasoned it out and
Yeah.
and see when, because it has to do with, remember in class I talked about the number wheel, and the overflow flag is when you cross over the negative, the most negative value to the most positive value. When you cross that border, that's when the overflow flag is set.
What about 0, 0, 1, 0?
0, 0, and 1, 0. Okay, let's check it out. So you have 0, 0, and 1, 0. Is that how you want to specify
Yeah,
it?
that's what I'm saying.
Okay. And
That's a positive minus a negative, right?
it's a non-negative minus a negative, and the result is negative. Oh, you're right. I missed one. Cool. Good job.
So would that also work for 0, 0, and 1, 1?
0, 0, and 1, 1.
Yeah.
Oops. Okay. 0, 0, and 1, 1. Okay, I need to realign things a little bit here. Okay, this one does not work because the end result is 0, 1, so the sign is correct.
Oh, that right.
Yeah. So now this is not a part of the answer. But I did miss the last one, which is 0, 0 minus 1, 0. The end result is 1, 0, but that would be incorrect. The sign is wrong. Okay.
Wait, you said the result was positive?
Okay, it should
Oh,
be
no, no, I got it
positive.
backwards.
It should be positive, but it's not, and that's why the sign doesn't make any sense.
It was 0, 0 minus 1, 1 was 0, 1, right?
0, 0 minus
1, 1.
1, 1
Was just 0, 1.
is 0, 1.
Okay,
Correct.
Yeah. So that came out positive.
Okay. Any other questions about number 1?
Still have 2 issues.
Okay. Number 2, consider the following code. So you look at this code here, it looks awfully like the homework assignment, except there are minor differences. So some people started to do this without reading through the instruction. I saw one person, filling all of this stuff here, and then went back to look at the memory layout. So I hope not too many people did that, because the memory layout is supposed to help you answer the question itself. All right, so let me see if I can display both the memory layout and, well, I can always use the editor to do this. Okay. Or I can just copy and paste it later on. So I'll just cut it, put it here, so I can finish this showing both the initialization. Okay. All right. So where do we start? We start with the first .int. Okay. So we always start with the least significant byte because the Intel processor is a little endian processor. So we start with a D4.
Right.
Okay.
Then it was 2, 0.
So we say D4, okay, and then the next one is going to be the 0, 2, because there's a leading 0 that is not
Showing.
showing.
Oh, see?
And then you
That's
have
That makes
4 more
sense.
zeros after that because it's a 32-bit. Remember,
Yeah,
in
yes,
class,
yeah,
I wrote on the whiteboard, .in, 32-bit. Okay, I did not quite spell out 32 bits. It's 4 bytes because I think,
I just didn't know how the 2D4 converted to D402.
well, but it's hexadecimal digits already at a byte border. So that means you just take it apart.
Well, I wasn't sure if it was D420.
Sorry?
I said when I was reading it, I was thinking D420 instead of 02.
Well, it looks like rewrite it so that hex digits, 2 hex digits, you know, so.
What was the thing? I
so it's
didn't know
like
where to add that 0 in.
And then think about it in memory.
Well, because with any number, if you don't specify the most significant parts, that means they're implied zeros. And that's not a base 16 thing, it's any base.
I didn't know.
But you use the first one.
Which one?
Extra one.
Then we'll send you back to remedial math. Where the whole class is struggling with division. We can talk about regular division, we're not talking about polynomial division either. Okay, so this one is 4, 0, which is the least significant byte, 2D, and then we have 0, 0, 0, 0. The next line, we have 2D, and then the 0, 4. And then this one is fairly easy, D0, 4, 2. And then, there's nothing I can do about the bytes, no trick I can do about the bytes. So we have 0, 4, and 2D. Okay, so, but we do have to know where is L1, okay? The original question was even trickier than this because in the original question, I took out L1. So you would have to refer everything relative to underscore start because underscore start is actually the address of this byte here. Then I decided, that's a little bit too much. I will just give you a label in between, just like the homework assignment. So I gave you, L1. So L1 would be the 2D, which is this one here. This is L1. So if you want to indicate, you just put a L1 on top of this, that will tell me that this byte is L1. Okay, above or below, either way is fine. So if you want to do it this way, you can just say L1 is here. So you don't have to spell out all the other ones, okay? L1 plus 1, L1 minus 1, because once you know where L1 is, that will help you answer the other questions. So are there any questions about the memory layout part? Once you get the layout right, okay, the rest is really, not too challenging. Okay, you can probably get it done pretty quickly. All right, so we want which bit pattern again?
42D0440.
Make sure the first 2 bits are right.
Oh, right there. Yep. So the lockdown value would be 42D0, but you have to read it backwards when you're reading it from memory. But this is our only chance, okay? The second instruction is our only chance to set the most significant 16 bits of EBX, because the other 2 instructions can only change the least significant 16 bit and then the least significant 8 bits. So this instruction is the only instruction that can set the most significant 16 bits, which means whatever you put into EAX is the only chance to specify that. Okay, so what we're looking for is D042 as a bit pattern.
Well, actually,
Sorry?
don't you need another leading 0?
Yeah, it needs a leading 0.
Yeah, you need a coming
Oh,
out
there's a
of
leading 0. Yes. Okay, very
the
good.
actual
There's actually a leading 0. I tricked myself. Okay, so you're looking for 2D04. Okay, 2D04. Okay, there's one here. 2D04. Okay, so only this one works, okay, because the other one is reversed, so that won't work. All right, so we want these 2 bytes to become the most significant 16 bits of EBX. But if you specify the address L1, that won't do the trick, because if you specify the address L1, it's going to end up copying this byte to the least significant byte, which is not what we want. We want to start copying from here, which is L1 minus 1, L1 minus 2. So this is just L1 minus 2, L1 minus 2. And then you also have to answer the second part of the question, which is what is in EAX after this instruction. And the answer is just L1 minus 2. L1 is an address, L1 minus 2 is also an address, and that's what EAX is storing after this instruction. The second instruction would use EAX as an address and specify and say copy those 4 bytes starting at the address specified by EAX into EBX. EAX has an address of L1 minus 2, which is this byte, so it's going to copy these 4 bytes into EBX. But because of little endian, when we spell out the bytes, it's going to be 04, 2D, 0000.
Don't forget the prefix of the 0x.
Okay, all right. Okay. Next line, we have to control the least significant 16-bit. We are going to overwrite the least significant A bits anyway, so we are not too concerned about that. We just want to make sure that the bit 8 to bit 15 of EAX is correct. So that is supposed to be a 04, and you can find a 04 here, you can find a 04 here. Either one will work, okay? You can pick either one. I'll just pick the first one. But if I want this 04 to be in bit 8 to bit 15, I have to start copying from here. Okay, so we're actually just copying L1 to BX. Put the L1 here. But if L1 is what we specify, then this part has to be consistent with that. So you have to say 042D, which is not changed, and then we have a 042D as a result. Okay, how come things are not aligned? I got one too many zeros here. There we go. All right. So now we are down to the least significant A bits of the register EAX, which is supposed to be 40. Okay, you can find 140 over here. You can find another 4. Oh, that's the only one. Yep, that's the only 40. So this is L1, L1 minus 1, minus 2, minus 3, minus 4. So the location is L1 minus 4. And as a result of that, EBX ends up with exactly what we want, which is 0x, 04, 2D, 0440. Is that okay? Did anyone use underscore start instead as an anchor? No one. Oh. In a way, it's easier because you just count backwards. There's no forward. There's no positive offset. Yeah. So in a way, I think it's less confusing. But you can use either one, or even check here. But that requires you to know the number of bytes of each instruction. All right, so that's for question number 2. Any questions about number 2? Okay, so we'll go ahead and run this program later on just to make sure. I don't trust my own answers. Okay. Sorry?
It really was.
Well, it's not the only answer too, because there's some parts of it you can pick one or the other byte. So you can pick your answer can be slightly different and still be correct. All right, question number 3 is a rehash of kind of what we did in class, except it's in the opposite direction. Because in class, I was illustrating how to do the, okay, in class I used Logisim to demonstrate this instruction. That's what I did. So this is the opposite. Okay. So what you want to do in Q3, in question number 3, is the opposite, because this is the right-hand side. Register C becomes the source. Okay, this is what we're copying from. Where we're copying to is not register A itself, but we are using register A as an address, and we are going to overwrite the location that register A is pointing to, and that's because of the asterisk here. This is a dereference symbol. I used the same notation in class, use the dereference symbol in class to mean dereferencing. All right. All right, so what we need to do now is just to specify, okay, how do we get it done? So the first thing you need to do is to make sure that register C, which is the 3rd register of the register bank, is the output, and it has to specify to the data bus. Okay, not the address bus. Yep.
Now make sure the 3, where does it say that? You had it written down. Register A is the first register, so that's index 0.
Index 0.
I was going to talk to you after the test, but I didn't have enough time. I just used 1.
So the other one is 3?
Yeah.
So 1 and 3?
Yeah.
Well, if it's self-consistent, you won't get a whole lot of points.
I will note on the bottom too.
Okay.
Assuming.
Well, but when we look at the register bank, it is 0 oriented.
Yeah, that's what I was going to ask about.
Okay. All right. So what we need to do is to look at the pathways of these lines. Okay. And I redid this picture a little bit so that we can actually see which line is the output of register 1 output and register 0 output, and which one is the register 1 input. these were not there before. You know, I specifically put these labels in so that you guys can more easily identify which line should I connect to the address line, which line should I connect to the data line. All right, so this is the data line. You can trace the data line. It goes all the way up here, and it can serve as the input, okay? But that's not what we want, okay? We want it to serve as the, what? Yeah, we want it to serve as the output. So it goes here, okay? This is the output, okay? So we want register 0 to specify register, okay, I cannot remember the.
We use one as the address.
Yeah,
the address
this
bus,
is,
one
this
is
is,
data bus.
yeah, but we want this selection.
Which one do we want?
Okay, let me switch to a text editor because I need to write it down on the side. Okay, mouse pad. There we go. All right, so let's take a look at the picture again. So the first thing we want to do is to specify reg 0 selection. Reg 0 out selection is 10. That's register C. Because that's going to provide the content. It provides the content onto the database. Okay. We have to enable the whole thing too. So register 0 out enable has to be a 1 because otherwise it's not going to output the whole thing. So with these two set, you know, this line register 0 output data is going to drive the data bus. You also have to set up the memory to do this. So with the memory, okay, let's go back to the picture. So with the memory, there are 2 bits or 2 bits that are important. One is the selection bit, which means, hey, memory module, wake up, you know, I'm talking to you. And the second one is to specify, is it a write operation or read operation? A 0 is default. It is already a write operation to begin with. So there's no need to specify to put a 0 into the load pin. But you do have to specify the select pin because otherwise the RAM module is not going to be selected. So you have to specify RAM cell equals 1 to make sure the RAM module is in fact selected. Yep.
Can you send the address and the value to store at the same time and then do?
Yeah, you can.
Yeah.
Yep. So we have more stuff to do on this same line. Yep. So the next thing we want to do is to specify register A to make it drive the address bus. This is the address bus here. It is going through a MUX. So now you have to track down which line of the MUX connects to reg 1 out data. And you track it down, it is number 1. So that means, you know, the selection pin, which is address driver select pin, it needs to be set to 0, 1. Okay, so we'll specify that. Address driver select is 0, 1. Okay, so just to make sure that we can see this. Okay. But then, you know, there's nothing driving this line yet. So we have to make sure that reg 1 out enable is selected. And because reg 1 out cell is by default all zeros because that's the given condition, you don't have to specify that. So getting back to here, we have reg 1 out selection being 0, 0, but once again, you don't have to specify that. I just want to put it here. It's not wrong to specify it, but if you don't have it specified, it's okay too, because everything that is all zeros are by default, you know, already here. Are there any questions about all these control signals? And that's, oh, yep, that's it. I think that's all I need. Yeah, the next one. The clock signal is by default a 0 because everything is a 0 to begin with. So if you want to, you can say, you know, clock is 0 here. Okay, it doesn't hurt, but it's not required. So the next clock cycle is just clock equals 1, but it has to be on the next line because you cannot have clock 1 being on the same line here. Then it will have a raised condition because you have all of these signals changing all at the same time. So whether the memory module will get the data in time to write it into the location, it's a timing issue. It becomes a raised condition in computer hardware design, and that's not desirable. So the clock equals 1 has to be on the separate line. Yep.
I'm just wondering, because if we were to write clock 1 right after that, do you take points off?
Yes, yes.
Because my assumption was that since that's the next operation will be occurring, that's the last one on that line. So it doesn't matter if it has to be on the
Nope, nope, because the question specifically say everything on the same line happens simultaneously. There's no ordering within the same on the same line. And let me see. Well, I thought I mentioned that. Okay, right here, I think it's right here. All changes of the same line are simultaneous.
But because when we do it on logic sim, we're individually clicking on one input line, so that's the way I was thinking.
Yep. Also the fact that the register 0 out is dealing with the data, and the register 1 is dealing with the address. Wouldn't we have them on separate lines, because it's not going to have a bus line?
You can have those on separate lines, but they don't have to.
Then after you're done with the both outputs, then you do a RAM select.
You can do that too, but they can all happen on the same line.
Yeah.
Because all of those operations, because nothing is getting there's no committing on the first line. They're all basically just, you're just putting the rails to the right switches, to the right location, but whether the train is going through, there's no train going through, okay, that's the point. The train is going through on the second line. So when the train goes through, then you have to make sure all the rails are properly switched and not switching during when the train is going through. So that's why the clock equals 1 has to be on the separate line. Is that okay?
No,
Questions? Okay. Because I can't see you. All right. So that's the answer. Okay, the answer to the third question is all of this stuff on the same line, and then clock equals 1 on a separate line all by itself. But if you break out everything into individual lines, that would also be okay. Okay, you're chewing up additional time, but it's not wrong either. Okay. All right. Last question, number 4. Okay, I think most people consider this one to be the most difficult one. Okay, so what we want to do is to take a look at the flags again, just to make sure that we understand what they mean. Yeah, one person actually came up and asked me, okay, what are these flags? Z, C, O, S. Well, we actually talked about it multiple times, and it is an open book, open notes, exam. But since I told that person, I had to write it out on the whiteboard, just to be fair. Okay. The Z flag represents 0, which means the result after the operation is 0. Okay. And then somebody asked me, what about the sign flag? Is the 0 not counting the sign flag? There's only one 0. Okay. When you look at 4 bits, 1000 is not 0. Okay, 1000 represents -8, which is not 0. There's only one 0, which is 0000. Now, what does that have anything to do with this? When the 0 flag is a 1, none of the other bits can be a 1. Okay, let's think about it. Okay. So let's think about, what if the 0 flag is a 1, and what is the other one? The sign flag is also a 1. How is that possible? This is 0, this is the sign flag. The 0 flag requires everything in the result to be 0. The sign flag is the most significant bit of the result. They cannot both be 1, so impossible. Okay, so you just say impossible. All zeros conflicts with most significant bit being a 1. Okay, I'm just using shorthand here because there's not a whole lot of space. Okay, and I would even refer to this as note 1. Okay, because everywhere you can see this pattern, you just refer to note 1. Note 1.
Pointer.
Yeah, pointers. Okay, I got 4 rows done already because it's the same pattern. Okay. All right. So if this one is done, let's take a look and check out the other ones. Okay. What about this one? This 0 flag is on, and then what is the other one? Overflow flag is a 0. Is that possible?
Not in my head.
In a subtraction, though. Okay. In an addition, it is possible, but in a subtraction. What is the only way you can get a 0, 0, 0, 0 as the result of a subtraction?
The
The two numbers are identical. If two numbers are identical, then you'll be subtracting a positive number from a positive number. You'll be subtracting a negative number from a negative number. In both cases, having a non-negative result makes sense. So that's why, this pattern is the same way. Okay, so you can say note 2, okay, impossible. Same number subtracting self. Okay, cannot result in the wrong sign. Okay, so everywhere you see this pattern, you just refer to 2. Okay, is that the only one? Only 2? Yep, looks that way. Okay. Okay, you guys have any questions? Okay, because if I can hear you, so can other people around you. Okay. You can use telepathy, because I'm not telepathic. I cannot. That won't bother me. Okay, so what about the carry flag or borrow flag? Okay, if the result is 0, can I end up with a borrow? Same reason, right? Impossible, because it's the same number subtracting itself. It is not possible to have a borrow. You only get a borrow when in unsigned interpretation, the second number is greater than the first number. Okay, but if both numbers are the same, you don't have to borrow. It doesn't make any sense that you have to borrow when those two numbers are exactly the same. Okay? Alright, so we got most of this done. This is possible. Okay? So how can I make the 0 flag being a 1 after a subtraction? Well, we just said it. And you can use any example. Remember, you can use any example. It doesn't have to be exotic. I will use the most unexotic answer. This is the most unexotic answer I can come up with. Okay, so that's done. We only have 7 possibilities left. Okay, so we can look at all the ones, every flag being a 0. It is non-zero result, there's no borrow, the result is non-negative, and there's no overflow. How about just 1 minus 0? Would that do it? Well, let's check. 1 minus 0 is non-zero, so the 0 flag is a 0. 1 minus 0 does not need a borrow, so the carry flag is a 0. 1 minus 0 is 1, which is non-negative. The sign makes sense. It's not overflow. And last, the result is non-zero, which means, non-negative, so the sign flag is a 0. Okay, so that get it taken care of. Alright, so this one requires us to have a similar setup, except the sign flag has to be a 1. What about -1 minus 0? Okay, let's check it out. 1, 1, 1, 1 minus 0, 0, 0, 0 is just 1, 1, 1, 1. Okay? It's non-zero, so the 0 flag is a 0. There's no borrow, so the carry flag is a 0. There's no overflow either. Subtracting 0 from any number cannot possibly trigger overflow, because it's just the number itself. And the sign flag is a 1, because the result is -1, so this will meet that requirement. This next one asks us, can we have a case where the overflow is a 1, okay, which means the sign doesn't make any sense, but the sign flag is a 0, okay? So that means, it's supposed to be a negative value, but it ends up to be non-negative, okay? So that usually happens when we subtract a value from the most negative value. So we'll check it out. Okay, so 1, 0, 0, 0 minus, which is the most negative value you can represent using 4 bits, and we'll just subtract 1 from it to make it cross over that boundary. So the result of this subtraction is 0, 1, 1, 1. Okay, it is non-zero. There's no borrow, because 1, 0, 0, 0 is representing 8 interpreted unsigned. So there's no borrow. There's overflow because the sign of the result does not make any sense, and yet the sign is a 0. Is that okay? Okay, moving on to the next one. So the next one, we have the sign flag being a 1. This one is a trickier one. The sign flag is a 1, the overflow flag is also a 1, which means we got a negative result when the result is supposed to be positive, okay? So that usually happens when you have the most positive number and you're subtracting a negative value from it. Okay, but there's a problem with this. The result of this is 1, 0, 0, 0, okay? Which is, this is fine. This is fine because there is a borrow, okay? This is okay. It is an overflow condition. And the sign flag is also a 1, so that's okay. So all of these requirements are met with this one, okay? This one here requires that we have a carry, which is a borrow in a subtraction situation, but no overflow and no sign, okay? So the result cannot be a negative result, and the sign has to make sense after the subtraction. But there is a borrow. Yep.
The previous one, you said there is a borrow, but that flag is not set.
Oh, that's right. Okay. So it is. So this one ends up to be impossible. Okay, this one is actually impossible. All right. But how would you explain why it is not possible? It's exactly because there's no borrow.
Overflow without carry. I was gonna say because you can't have an overflow without a carry or a borrow.
Okay, let me see if you guys remember this, because I kind of remember that we talked about it, but I'm not sure whether you guys remember it. Okay, so when you look at a subtraction, okay, so let's say we have AB minus CD, and the end result is DEF, okay? So when you look at a subtraction like this, what is the definition of the overflow flag? The overflow flag is, okay, something or something. Do you guys remember this?
Yeah.
Okay, so let's think about it, okay? So if A is a 1, okay, then we want C to be a 0, so you're subtracting a non-negative quantity from a negative quantity. And E is going to be 0 as well, and that way the sign does not make sense. Is that okay? So that's one way to make the sign not make any sense. The other way is to have A being a 0, so you start with a non-negative number, you subtract a negative number, and you end up with a negative number. So so these equations specify when the overflow flag is a 1. Is that okay? And one of these bits turns out to be our sign bit. Which one is our sign bit?
C.
E is our sign bit because it's the sign bit of the result of the operation. Okay? So when you look at this, when you combine this with the fourth row, okay, which is this row here, we want overflow to be a 1, which means at least one of these two has to be true. Okay? We also want the sign flag to be a 1, and the only way to make that happen is to pick out this term, because this is the term where E is a 1. So that means A has to be a 0 and C has to be a 1. That guarantees a borrow.
You didn't explain it that thoroughly. Just put the equation up there and the AC.
Yeah. But you can always just say that if the most significant one being 0 minus 1, regardless of what the other bits are, 0 minus 1 guarantees a borrow. That's it. So that's impossible. Okay, impossible because okay, 0 minus 1 as most significant bit guarantees borrow. Okay, here we go. I mean, you can write it in a different way, but that means everything that ends up with 1 1 can be explained exactly the same way. So we put a note after this. I think 3 is unused, so let's say we use 3. So this one can be explained exactly the same way because it has 1 1 here as well.
Yep.
Oh, I take it back. It has to be a 0 over here. Okay, so I take it back. I take it back.
No shortcutting on
And with this, this one we can actually make it happen because we have a 0, 1, 1, 1, minus 1, 1, 1, 1, that will make it happen. Okay. All right, so this one has only the carry flag set, but everything else is cleared. So we want to end up with a borrow, but we don't want the sign flag to be a 1 either. Okay, is that possible?
It should be, because you can borrow and still. An overflow flag is off. So like.
Okay, well, let's take a look at the division. Okay, so let's take a look at the division, but this time we'll take a look at the full division here. Okay, so we always have a 0 here. Okay, so this is a full division. We are looking at this borrow flag here, and we say, okay, what can contribute to this borrow flag? A minus C can contribute to the borrow flag. This bit minus this bit can also contribute to this borrow flag here. So let me just give these names. Okay, so this is bit X, this is bit Y. So A minus C can contribute a borrow. X minus Y can also contribute a borrow. So the question is it possible to set this up so that B is a 1, but E is a 0? Because that's that's the bit pattern here. What do you think?
I say yes.
Okay.
Because if the borrow flag is set, then that means
That's what I'm looking at. So this would be a bar.
number you're subtracting
From there.
has to be greater than the one.
That's also 0.
CD as a number is unsigned is representing a number that is greater
We're
than
supposed to go
AB. That's what the borrow flag means. Yep. So CD has to be larger than AB, which means
In order to do the B, for it to be bigger, it'd have to be signed.
That's what I was doing for all this.
In order to set the borrow, right?
well, I'm actually trying to think of a case right now.
Try a 0, 1, 0, 0 and 0, 1, 0, 1.
Okay, say it again.
0, 1, 0, 0.
0, 1, 0, 0, and
0, 1, 0,
0, 1,
0, 1.
0,
We want
1.
that, though, 'cause we don't
That
want
won't work. I can tell right away. Because the result of this is just 1, 1, 1, 1.
It needs to carry off the screen.
Yeah.
Oh, that one's can't happen. But can you get it carried? That one.
Maybe that would work.
Right.
But that won't work either. That won't work. Okay, let's check it out.
That's not gonna borrow. That's gonna be a 1.
I think it's not possible. This pattern here
Nothing borrowed.
with just the carry is not possible.
I think that's gonna set the sign.
Hmm?
That's gonna set the sign flag, isn't
I think so. Okay, let me fill in these blanks first, okay, and then we'll go back to that one and explain it. Because as you work on the table, you start to gain insight on the other ones. When you figure out the answer to the ones that are possible, it will give you insight to the other ones. So this one, we want to end up with a sign, and we want it with a borrow. That's pretty easy.
That's
0 minus 1 will do it, because this will give me F and a borrow. So borrow is okay. Sign flag is a 1. It's okay. It does not give me an overflow, okay, because 0, 0, 0, 0 minus 0, 1, 1, 0, 0, 0, 1 is supposed to be negative, and it is negative, and it is non-zero. So that's fine. Okay, that's not a problem. Okay, so we only got 2 rows left. Okay, we got this row and we got this row here. This one is a carry with an overflow but no sign. This one is a carry with no sign. So they do share a common trait of having the carry but no sign. All right, so what we want to do is to look at the combination. There we go. All right, so what we're looking for is a pattern where this bit is a 0, this bit is a 1. That's what we're looking for. All right, so now we have to take a look at, okay, how can this bit be a 0? A 1 here and a 1 here would make this a 0. If this is if these two bits are the same, then they won't be contributing to this one here. So this one can only be contributed from this part here. Is that okay? Okay, so I'm constructing a case, to make that happen. Using only 2 bits. If I can make it work with 2 bits, I can make it work with 4 bits. So I have a 0 here. I need a 1 here. And the result, I need this is guaranteed to be a 1.
Right.
And I want a 1 here. If I want a 1 here, that means I need to borrow from the other digit as well. So we have a 0 and a 1. That's the only way to guarantee a 1 here. Yep, that will do it. 0 minus -1 is 1. That it doesn't have any overflow. It does have a borrow. Okay, so that's how we can make it happen. So this one is possible. Wait. Yeah, it is possible. Okay, so we have that pattern, which is, what is it? 0 minus -1. Okay, 0, 0, 0, 0 minus -1 will make that happen. One case left is this one. Okay, we want something like this, except this time we want the overflow to be a 1. Okay, if you take a look at this pattern here, it is not possible because we want the end result to be a 0 here. So if you look at these bits, 0, 1, and a 0, that doesn't fit the pattern of an overflow condition. Now there's only one other chance to make this happen, which is a 1 here, a 0 here, and then you have a 1, and you need a 1 more here, and end up with a 0 here. That's the only other way to, well, this won't work because there's no borrow in this case. Right? There's no borrow.
Right.
All right, so to make it borrow, we have to force this one to be a 0, so we need to borrow from the other one, but that will turn this into a 1. So I think this combination is also impossible. Having a carry and a borrow and an overflow set at the same time, but no sign. Let's check one more time. I like these questions.
You have to borrow and get a 0 from that.
Okay, you need to borrow.
Right.
And we need an overflow. Okay, the overflow is the easy one, okay, because this really locks down the pattern because we are looking at the sign being a 0. If the sign is a 0, this is the only way to make it happen, to make overflow but no sign. Is that okay? And what this is representing is we have a 1 something minus a 0 something. Okay, this part I don't know yet, and ending up with a 0 down here. Okay? But because we also want to lock down the carry bit to be a 1, so that means we also want to make sure that this is a borrow. Okay? 1 minus 0 is guaranteed to be a 1 because this is a half subtractor. Okay? And in order for this to be a 0, we need a 1 here. Is that okay? But that means there's no way I can set this borrow. So the case is impossible. Is that okay or not? Shall I explain it again?
Enough brain cells left.
No, it's pretty clear.
No, the brain cells are there. The question is there juice left? Okay, but I do want to kind of go through this one more time, okay? Because this is all about constraint stuff, okay? Have you guys ever taken those IQ, not IQ, but those they're problem-solving, stories where they will say, okay, this person likes this person but does not like that person, and they will ask you, okay, can we arrange these people to sit together and they don't quarrel in any way? It's one of those things. It's constraints, okay? You have to identify the constraints. Okay, so let's do this one more time. Okay, so this is for this case here, okay? All right, so the first thing we do is we look at the most constraining stuff, okay? The overflow flag is one of the most constraining flags because if the overflow flag is a 1, it can only be a 1 either because of this or because of this. Okay, so that really locks down what kind of numbers you can be subtracting. But we are not only locking down the overflow flag, we are also locking down the sign flag. So knowing that the overflow flag is a 1, but the sign flag is a 0, that means we can only have this pattern here. Now when you have this pattern, then you have just locked down the first number to be 1 something, 1 blah blah blah, and the second number can only be 0 blah blah blah. Is that okay? How we lock down, the most significant bit of the numbers that are being subtracted? Is that okay? Because that's the first thing to lock down. But by the same result, we are also locking down this to be a 0. So we just lock down 3 values on the same column, and these are half subtracted columns. Once you lock down this 1 and this 0 as a half subtractor, this has to be a 1. There's no escape. That one has to be a 1. But in order for this to be a 0, this has to be a 1 too. But then you look at this subtraction, 1 minus 0 does not have a borrow. You look at 1 minus 1, it doesn't have a borrow either. But those are the only ways I can have this borrow flag set. And yet none of these can set it. So that's why it's not possible. Is that okay?
Extra points.
Extra points.
Whoever has
We don't
these.
use the second part, not AAC, because it would be assigned, right?
Say again?
We're using the first one because it's not going to be signed. We're using the not AAC.
Correct. Yes, because the sign flag is a 0, so that means E has to be a 0, and that really helped to kind of lock down what possibilities we have. So the explanation is going to be a little bit long here, okay? Okay, I guess if you say it's not possible, that's going to be okay. But the reasoning is that, okay, instead of trying all possible combinations and figure out, oh, none of these will trigger this particular flag combination, I can reason it out. Okay, just use the constraints to help lock down. Okay, this is not possible because what we are asking for is it's just impossible to achieve. Okay, so because long explanation.
See YouTube.
See YouTube, yes. So are there any questions about this one?
I may have got a couple combinations I shouldn't have.
Some over.
But I got most of them.
Half.
And the bottom half for sure.
Yeah, the bottom half is actually
It's kind of gimme.
but you can also use that explanation here. This one also has a 1-1, so you have choices of explaining why this one is not possible. So you can see how many are actually possible. 1, 2, 3, 4, 5, 6, 7. So 7 of the 16 combinations is actually possible. Yep.
Can we expect these to be graded?
Say again?
When can we expect these to be graded?
Oh, it's gonna be brutal on me because I have 4 exams this week, and with the exception of cisp310, which only has 20 students, all other classes have 50 students.
What about the homework? You start grading the homework.
Well, I'll get to the homework after the test because the test carries a lot more weight than the homework.
You'll know if you passed.
And if you screwed up the homework, it doesn't matter. You already took the test.
If you screw up the homework, and you ace the test, you're still okay.
Right.
But the other way around is not.
There's nothing to learn from it at this point. at least for this test.
Well,
I got
but
time.
with all the homework, at least I gave you guys the solution.
You can test
Right.
them, all of them. You can test to know if you got
I already know I got A copy. I'll get the next
So did you guys do okay? I mean, I can stop the recorder now, so you won't be recorded.